Hello, let's do some more basic algebra. This time it gets a little bit weird. Math backwards. What do I mean by that? Just did a whole video on math forwards, going from kg to milligram dose, which you can't draw up, but you do need for your record, into milliliters, which you can draw up and needs to be delivered to the animal. But what happens when your doctor throws something at you, like they just say, I want 0.23 cc's of Serenia on that cat. And you're like, okay, but you can't really write that in the medical record. You shouldn't write that in the medical record. It doesn't look correct. So how would we do that? Well, the quick and dirty way, oh, golly and goodness, go away. Thank you, Samsung, for being weird. Let's say I'm writing it in the medical record now. I gave Serenia at 10 mg per mil, 0.23 cc's sub-Q at 10 a.m. All right, so you can write that. That works. That explains mg per mil concentration on the bottle, and then somebody can reverse it and figure out what is that milligram dosage, or even better yet, what is the concentration the doctor was thinking of. So we can do all of that when we have basic stuff, but sometimes you're responsible for writing down the MIGs and the KIGs and the whole 9 yards. So let's figure out how in the world we would get there. Put my line back here. I'm just eraser happy. So let's go back to that 2.3 kg animal. And we have Serenia. And we read the bottle. The bottle says 10 mg per mil. Okay, now I have my bits of information that I need. So if you follow this formula up here, you know the mils. The doctor said, give this, and you did. But now you have to write it in the record. So if you take your mils times mg per mil, which is what the bottle told you, you will end up getting milligrams. And if you divide your milligrams by how many kilograms the animal is, you will end up with mg per kg. So that's what I mean by math backwards. Normally we'd start off with how many mg per kg do I need to give this animal? And we're starting with the mils we gave the animal. All right, so let's try this out. I know I have how many mils. That's what the formula says. I'm starting with 0.23 mils, and then I'm going to take it times mg per mil. That's on the bottle. That is my concentration on the bottle. So if I take this times 10, my answer in milligrams is 2.3 milligrams. Excellent. That's good and all, but what if you are trying to write up your VTS report? Sometimes they need you to write it out as mg per kg. Well, that's fine. We can do that too. We'll take our milligram divided by kilograms. All right, so 2.3 milligrams, I already got that on my calculator, divided by 2.3 kgs, and that equals 1 mg per kg. There you go. And that makes sense because Serenia 99.999% of the time is going to be 1 mg per kg. Totally makes sense. Buprenex. Let's say your doctor says, yeah, that cat needs 0.15 cc's of Buprenex every 8 hours by mouth. Okay, sure, fine. But that doesn't help you, right? Because you can write cc's, but you know we have to write mg, we have to write mg per kg, we have to write something other than that in the medical record. We can always write Buprenex 0.3 mg per mil, comma, 0.15 cc PO at whatever time. You can always write that. That's fine. But it's a little bit more professional looking to write MIGs or mg per kg. So we'll just do our math backwards again. Doctor said 0.15. Got it. So that's my mils I'm starting with. If I take that times mg per mil, again, if we're looking at our equation, mg per mil, which is concentration, and that is on the bottle, always on the bottle, times 0.3. That's going to give me 0.045 mg. Got it. All right. Now I'm wondering though, yeah, but what dose is that? Because if I look back in my plum, let's say the cat had a bad reaction to this. They got way too high. They got way too squirrely on it. And now they're euphoric to the point of becoming dangerous to themselves. And you're going, well, how much frickin' drug did I didn't think 0.15 was a big enough dose for this animal. You know, you're trying to logically work it out in your head. That's okay. Let's go a step further and figure out mg per kg. Because then we can look in our formulary, the plum or the pay pitch, and we can decide, oof, did I give too much? Did I give too little? What's going on? Maybe the cat just doesn't like Buprenex. Also a possibility. So if we take that 0.045 mg that we mathed out, and we'd again mg divided by kg, so divided by the 2.3, and that comes out to, on the calculator over here on the left, you see 0.019565, but that rounds up to roughly 0.02. So 0.02 mg per kg, great. That's a midline dose. You can do that. So that should not have been the problem, and that's how you're going to double check those things if you have to write in your medical record to prove that you gave the correct dose and dosing to the animal. And the animal is just having a weird reaction to Buprenex. It can happen. So if we look at metronidazole, again, we take that mils my doctor told me to give, 2.3, times the mg per mil, or the concentration. I'm going to get 11.5 mg. All right, we can write that in the medical record next to the 2.3 cc's, and we've completed a good chunk of our information. But again, what if we go back and somebody says, well, what was the actual dosage, this here mg per kg dose of metronidazole? Because you could go much higher on metronidazole. Maybe the doctor is like, oh gosh, we should increase it because I'm worried with how much yada 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 yada. Okay, so whatever. So you're thinking, okay, now I got to figure that out. That's okay. We again, we know if we take our mg divided by kgs, we're going to get mg per kg. All right, so we have up here 11.5 mgs, and if we divide it by their kgs, which is 2.3, we're going to get 5 mg per kg. Excellent. Now that math turned out really lovely. The Buprenex math was kind of gross. It was 0.019. This one turned out great. That's always a feel-good moment, but don't always expect it to turn out great. You just have to hope it turns out great, right? So if we go now, cefazolin, again, doctor said that is what I was to give the animal. Great. I can't write that in the medical record. So I take my mils, 0.51. I'm going to take it times the mg per mil, or the concentration. And that's going to be 51 milligrams. Okay? And now, I'm just a curious guy. So if I'm so curious, I need to figure out, well, what does that come out to be, mg per kg wise? I want to know. I'm curious. You take that, mgs, divided by kgs, okay, divided by the 2.3 kgs, and you're going to get 22.17 and some change. We don't have to write all that, mg per kg. And that's very, very close to 22 mg per kg, which is 9 times out of 10 the dose you start with for cefazolin. Now, why do I keep saying that? Why do I keep saying, well, yeah, so that's the right dose, that's the right dose? Maybe you don't know the quote-unquote correct doses yet. That's okay. But as you grow and you learn, eventually somebody will say, give cefazolin, and you yell out, is 22 mg per kg okay? And they say, yeah. Well, that's because you've done all this math. You've done this math 100 times. And now you know what standard dosing is. And you just kind of go, I get it. So it's all working in your head. All right, so this is the point where you can pause and finish off what a 6.9 kg animal would be and what a 5.7 kg animal would be. And then we'll pick it up here in a minute when you turn the video back on. Now if we keep going, if we have, somebody said 6.9 cc's was given to this animal, all right, 0.69 times, again, mg per mil, which is concentration, and that's on the bottle, 10, you get 6.9 mg. Perfect. 6.9 mg then divided by kg, which is 6.9, that'll always get me 1. Oh gosh, 1 mg per kg. 1 mg per kg. And that is now the dosage that you were given from the plum, from the formularies that are out there to give to this animal. All right. Now I'm just going to start making up random numbers and seeing what happens. Because I didn't fill any of my cc's in, I figured we can go through this and make some mistakes together. That way we can see what happens when we do that. So let's say this 6.9 kilogram animal got Buprenex at 0.92 cc's. All right, so I gave 0.92, and I'm going to take that times the mg per mil, which again is the concentration on my bottle, times 0.3, and that is 0.276 mgs. And then if I take that mg divided by kilograms, I should get mg per kg. So I take this number divided by the 6.9 kilograms, and I get 0.04 mg per kg. Now I can tell you that is the much, much upper end of Buprenex, but if you read through your formulary, it would still be considered appropriate to give that dose if somebody was indeed needing an extra dose, higher meds, something, something. The more you read about Buprenex, the more you'll realize that if they're in true severe pain, Buprenex isn't going to cut it. But even at a higher dose like 0.04 mg per kg. But that's not where this conversation is going. The conversation is just, if I get 0.04 mg per kg as my math, and I know I did it right. I know I had somebody looking at it, and they confirmed it was 0.04 mg per kg. Okay? And then I look up in the formulary that that is a correct dose. Okay, that's fine. But then you can say to yourself, what is now happening with my patient? Are they happy, euphoric, comfortable, a pain score of 0 to 1 rather than a 4 to 5? You know, those are the things we're trying to assess on top of giving all these meds. And I know that's a little bit beyond the scope of just doing some backwards math, but you may as well see where I'm going with all of this and why I think it's important to be able to do math backwards. All right, metronidazole. Let's say I gave metronidazole to a 6.9 kg animal, and let's say I gave 11 mils. All right. So if I take mil times mg per mil, concentration that's on the bottle, I'm going to get 55 mg. And then I'm going to take my mg divided by kg to get mg per kg. So that is 6.9 kgs. So that's 7.97 mg per kg. And that's still an okay dose. Let's say your doctor is panicked and they say, you gave 11 mils, that's wrong. And you're like, you told me to give 11 mils. Maybe they meant 1.1. Maybe they said 11, but they meant it for something else. You never know. But now you have to go back and figure out the math to make sure that's not an inappropriate dose for the animal. Again, metronidazole is usually anywhere between 5 to 10 mg per kg. So 7 or 8 if you round up. It's kind of a midline dose. I wouldn't get too worried about that. But when you would get worried is if the animal is having a metronidazole-like reaction, which can happen in any pet. You unfortunately will not know who is going to have a bad reaction to metronidazole. And again, 8 mg per kg or 7.97 mg per kg is not inappropriate. That is within the dose range. But you never know who's going to react how, right? So that's why we figure out our math. Moving on to cefazolin. If I take a random dose, let's see if I can get crazy here. So this oh, I'm so sorry. I keep touching buttons and stuff is showing up on my screen. Let's say I gave 44 mils of cefazolin to a 6.9 kg animal. We're going to go really nuts this time. We're going to be super inappropriate. That's fine. Let's see what happens. If I take 44 times 100 mg per mil, I'm going to get 4,400 mg. All right, so that happened. Excuse me. And then you take that number divided by kilograms to figure out what is that mg per kg dose I just gave. So 4,400 divided by the 6.9 kilogram animal. Ooh, so that's 637 mg per kg. That is outrageous. So first and foremost, though, I know you're all screaming at me. I would never give a 7 kg animal 44 mils of anything. No, you wouldn't. No, you wouldn't. I already know you wouldn't. But again, sometimes stuff happens, right? So you're looking at that 44 mils and you're going, oh, and maybe you math it out and you say, doctor, just by the way, that 44 mils ends up being 637 mg per kg, and I already know cefazolin tops out somewhere near 30 mg per kg. I just wanted you to double check that that 44 mils is true. And they're going to say, oh my gosh, yeah, I didn't want 40, no, that, okay. And then there's probably something silly like it was supposed to be 4.4 mils, right? Because that's just what happens. You get going. But you did your due diligence. You did your math. You busted out your formulary and you said, that seems wrong. So you're double checking these things. And you know how? Because you are doing math backwards. So let's go back up here. We've got a new pet, 15.7 kilograms. So going back again, if I just start randomly picking numbers, 1.6 mils I'm going to give to that animal of Serenia. Now if I take that times mg per mil, or the concentration that's written on the bottle, that gives me 16 mg. Then I'll divide that by kilograms of the animal, 15.7, and I'm going to get 1.0, and let's round to mg per kg. All right, well, that's pretty darn close to 1 mg per kg, because as you're learning and you're studying and you're busting out your flashcards, you quick found Serenia and you learned, okay, it's supposed to be usually 99.99% of the time 1 mg per kg, and it turned out maybe this doctor just rounded a little bit. Great, it's still pretty darn close. Again, if you're at all concerned, should bring it up. But that usually that 0.02 doesn't mean a whole lot. All right, so let's go to Buprenex. So for this kid, I'm going to give 2 mils. 2 mils of Buprenex to this animal. So if I take my 2 mils times my mg per mil, 0.3, which is the concentration on the bottle, I'm going to get 0.6 mg that I gave, divided by kgs, 15.7, and I get 0.038 mg per kg. Again, upper end of the dose, but you never know. Some doctors prefer heavier doses, some doctors prefer lower doses. Maybe this is the dose that they're going to use to send the animal to the hospital because they're so aggressive and scared that they're going to try a heavier dose by mouth to make the animal happier. Who knows? Maybe. Your point is that you're just going to look these things up, and if something makes you nervous, you go ask about it, or at least you know you can record correctly in the medical record what happened. Next number, metronidazole. For this kiddo, let's get nuts. Let's say I gave 35 mils metronidazole to a 15.7 kilogram animal. So if I take that 35 again times mg per mil, the concentration on the bottle, well, metronidazole technically comes in a bag. That's okay, same idea. We're going to get 175 mg, and then you divide mgs by kigs, 15.7, and we get 11.1, let's round 5 mg per kig. Now, like I said, metronidazole usually only goes up to about 10 mg per kg because you can start seeing metronidazole toxicity past that. There could be a reason the doctor goes above that dose. Who knows? But that's okay because you figured it out and you say, hey, doc, wait a minute. That is above standard regulations. There you go. All right. Cefazolin. Let's get nuts again. Let's say maybe this animal can tolerate 44 mils. Let's see. So if I have 44 mils times that concentration, 100, that's still the same number, 4,400 mg. This time it's a different weight. So if I take 4,400 mg divided by 15.7, oh dear, it's 280 mg per kg. All right, that's still pretty insane. Probably should be that high. But again, just trying to show you how the math works out, how to protect yourself when you need to if you think, good Lord, that seems like such a big dose, and just how to write it correctly in the medical record for when your doctor throws out a cc, but you can't write that. You know you can't write that. So now you've seen how to do that. I hope it helps.